Hey everyone, so it's my turn to present something for you guys. So I've been trying to come up with an idea for this video all week, and I thought of nothing. And that's when it hit me. Talk about zero. So in this video, I'm going to talk about a little bit about the history / the concept of zero. So zero as an idea of a number that we use every day took a while to be accepted and to actually start being used because zero was not a practical idea. For example, when we start counting things, we don't count starting at 0, we start counting at 1. So because of that, there wasn't really a need for 0. The idea of like emptiness was present at the time though. For example, if someone wanted apples and they didn't have any, they did have that concept of having no apples, but they didn't have a number for it. They didn't say I have 0 apples. So again, the idea of 0 as a number wasn't very practical in ancient times. But then in writing, however, writing certain numbers became a bit confusing. Before the Babylonians, most writing systems used different symbols for different numbers. For example, Roman numerals uses L for 50, X for 10, C for 100, and so on. So different combinations of those letters represented different numbers, and there wasn't much confusion about that. The Babylonians, however, only had two symbols for their numbers. They had a single wedge, which represented 1, and a double wedge, which represented 10. Now, the way that they wrote their numbers is very similar to ours in regards to having different positions represent different values. For example, in the number 33, the 3 in the ones place represents how many ones you have, and the 3 in the tens place represents how many tens you have. So even though we use the same symbol for both those numbers, they represent different quantities. So the Babylonians had a very similar idea. So issues came up when they had two of the same symbols right next to each other. For example, if you have two single wedges next to each other, is that the number 2 where each wedge represents the number 1? Or is it the number 61 where the rightmost wedge represented 1 and the leftmost one represented 60? Quick side note, the Babylonians had a base 60 number system, meaning that where we have a tens place, they have a 60s place. Where we have a hundreds place, they have a 3600 place, and so on. So because of this issue of having a bunch of different numbers represented by the same symbols, the need for a placeholder arose. And thus, that's how the idea of 0 was kind of born. At first, 0 was just that, it was just a placeholder. On its own, it meant nothing. Let's fast forward and think about 0 as an actual number. Usually, in addition, numbers, when added up together, get bigger, and when subtracted from each other, get smaller. But if you add or subtract 0, nothing happens. Similarly, when you multiply numbers, imagine holding a rubber band with all the integers on there over a number line. And so if you multiply by 2, you stretch that rubber band so that the number or the tick mark that had 1 on it is now over the 2 instead of the 1. And when you divide by a number, let's say 2, you relax the rubber band so that the tick mark that was over the 2 before is now over the 1. But when we think about multiplying any number by 0, it's equal to 0. So now all of a sudden, that rubber band, all of the tick marks are at 0. And if we divide by 0, poop hits the fan, guys. Don't do it. It destroys mathematical logic. For example, if I divide by 0, then I can prove that Winston Churchill was a carrot. To start that proof, we're going to say A and B are equal to 1. So then, because A and B are both the same, then B squared is equal to AB. And that's equation 1. And since A is equal to itself, then A squared is equal to A squared. That'll be equation 2. Now if we subtract equation 1 from equation 2, we get that A squared minus B squared is equal to A squared minus AB. Now we can factor both sides and we get that A plus B times A minus B is equal to A times A minus B. So then we can divide by A minus B from both sides and we end up with A plus B is equal to A. Subtract A from both sides and we get that B is equal to 0. Now we originally set B equal to 1 at the very beginning, so then we get this equation that says 1 equals 0. Now clearly we know that 1 is not equal to 0, but for the purposes of this proof, we're just going to accept that that's true. So assuming that 1 equals 0 is true, let's consider some things. Winston Churchill has one head, and because 1 equals 0, that means he has 0 heads. He also has 0 leafy tops, but because 0 is equal to 1, then he has 1 leafy top. Now if we multiply that equation by 2, we get that 2 is equal to 0. So then, assuming that that's true, Winston Churchill has 2 legs, which means he has no legs. He also has 2 arms, which means he has no arms. Taking it even further, let's multiply the 1 equals 0 equation by Winston Churchill's waist size. So if we do that, then we get that his waist size is equal to 0, which means that Winston Churchill tapers to a point. Let's consider what color Winston Churchill is. Take any beam of light and select some photon. Multiply by the wavelength of that, and we get that Winston's photon's wavelength is equal to 0. Now multiply the 1 equals 0 equation again by 640 nanometers, and we get that 640 is equal to 0. And so thus, if we put those two together, we get that Winston's photon's wavelength is equal to 640 nanometers. So that means that any photon that comes from Winston Churchill is bright orange. If we summarize everything, we have that Winston Churchill doesn't have a head, and instead he has a leafy top, that he has no arms and no legs, that he tapers to a point, and then he's bright orange. So clearly Winston Churchill is a carrot. So when we go from equation 4 to equation 5, we divided by a minus b. But from the very beginning we said a and b are both equal to 1, so then a minus b is 0. So when we divided 0 to both sides, we got that 1 is equal to 0, which clearly is not true. So in this proof, dividing by 0 let us prove that Winston Churchill was a carrot. So if we go back to the Greeks, this idea of 0 frightened them. It was a dangerous idea to them. 0 represented this kind of void to them, and they didn't like the idea of void. But they also didn't like the idea of infinity. They tried to reject these ideas of the void / 0 and the infinite / infinity. But it wasn't easy to do both at the same time. To make this more clear, let's think about the idea of history. So history is a sequence of events. Now if infinity doesn't exist, that means that there cannot be an infinite amount of events, meaning that there was a first event. Let's call it creation. And so considering that that was the first historical event, what existed before that? Void. If you want to reject the idea of void, then that means that the universe has always existed and will always exist in the future, aka infinity. Rejecting both the idea of void and infinity became a problem because once you rejected one, that meant the other one existed. And so they couldn't do both, they couldn't reject both at the same time. And that's why the idea of 0 frightened the Greeks so much, and that's why they rejected it for so long. Obviously we know that today the idea of 0 is a widely accepted thing. 0 became an interesting concept to study and to determine properties of. And that's where I'm going to stop, and I hope that you guys were interested in what I said. And remember, don't divide by 0, because otherwise Winston Churchill is a carrot.